Okay. We are now going to talk about general exponential rules. Here we go. Sorry, it's messing me up. Derivatives for general exponentials and logs. Okay. And before we do the rule, which the rule is actually very easy, it's actually similar to what you were doing in the last lesson. I'm going to just show you how it comes about. Okay, kind of like a proof of it. Don't get scared of the word proof. It's just showing you how we can use what we learned yesterday to do this lesson. So if I went to rewrite this as y equals e to the ln of 2 to the x, okay? Remember e and ln cancel? So I'm allowed to do that because it maintains this same equation, the equality of the equation. You know, you can add one to one side and add one to another side. That maintains equality. So this is maintaining equality because these two cancel and you'd be left with 2 to the x. Well, now if I let this be my u, ln of 2 to the x, and I follow the property that we did yesterday where I took the power in front, so I had x times the ln of 2. Well, what is the ln of 2? The ln of 2 is just a coefficient, really, because it's a number inside your calculator. So what would you do if it was just like, how would you take the derivative of 2x? You would just say, oh, it's 2. Or if it was 3x, you would just say 3. Well, if it's ln of 2x, the derivative is ln 2. So let's go back over here. This again would be an e to the u problem. And from what we learned in the last lesson, the derivative of e to the u is e to the u times the chain. So now if I go back to replace my u with ln of 2 to the x, and then I attach the chain, which is ln 2, I can then go back and cancel that out and call this 2 to the x ln 2. And that's the derivative of that. So what would be a good generalized rule for any a to the x power, any base, any 3 to the x, any 7 to the x? We could have actually done this with e to the x. Well, just like e to the x, you write it again, and you're going to now, if this is not a base e, you're going to attach ln a. If, however, that x happens to be a u, any other number other than x, okay, any other letter other than x, you're going to write it again. You're going to attach ln a, which is the base, and then you're also going to attach the chain, which is the derivative of the exponent. Okay? So we're going to practice this. It's not really as scary as it sounds. It's literally what you were doing yesterday. You'd write again and you attach the chain of the exponent. But you're just what you're doing right now, because we could have done this yesterday. We just could have done e to the x. The derivative would have been e to the x times ln e. Well, what is ln e? It's just 1. So it's just the same idea. You're attaching now the ln of the base and the chain. All right, so let's try this one. 7 to the x. Write it again. There's no extra chain here. You could put times 1, but now you have to just attach ln of the base, 7. Done. That's it. All right, let's do this one. 3 to the 2x minus 5. So we're going to write it again. 3 to the 2x minus 5. We got to put ln of the base. And we got to attach a chain if there's anything other than an x. So the derivative of 2x minus 5 is 2. Now, students get confused because they think they're allowed to do 2 times this 3. No, no, no. Okay? You cannot do 2 times 3 to the 5th and call that 6 to the 5th. That is a no-no. Okay? If they were the same base, you could. You could change it and be like 2 times 2 to the 5th. Well, that's 2 to the 6th power. but they're not the same base. So what do? You just rewrite that 2 in front. You put like a little multiplication symbol, and you put the ln3 here. But honestly, if you leave it like that, that's still very, very good. All right, we're going to get to it. We always got to throw in a product rule and a quotient rule somewhere. And how do I know this is a product rule? This looks weird, right? X times, or x 2 to the x, but a number and a letter next to each other mean multiplication. So we're going to do product rule here. So we're going to do first times the derivative of the second, derivative of any number to a base power, you write it again, times ln of the base, times this chain, which is 1. So first times derivative of the second, plus the second, times the derivative of the first, which is 1. And you can put a 1 there, but I'm not going to. Now that's fine with me, just so you know, depending on who your teacher is, you can factor out a 2 to the x, since this is all multiplication. So here's your one group and here's your other group. You can do 2 to the x times, you'd have x, you'd have the ln2, then you put your plus, and then 2 to the x from 2 to the x is 1. And that would be your answer. Now for this one, looks like a quotient. We're going to do quotient rule. All right, so quotient rule would say denominator times the derivative of the numerator. So the derivative of 3 to the x would be 3 to the x ln 3 times that chain, which is 1, minus numerator times the derivative of the denominator, which is 3 to the x ln 3 times that chain 1, and then the derivative of 2 is 0. And you're going to put that all over the denominator squared. Now, you do need to do some cleaning up about this a little bit. You're going to see how you can clean it up. You can either like factor things out or not. But if you notice the two groups right here, here's a group on top. They both have a 3 to the x that they're multiplying. Okay? So I'm going to factor out that 3 to the x. If I factor out a 3 to the x, let's see what I'm left with. Well, from this group, I'd be left with 3 to the x plus 2 times ln 3. And from this group, I'd have a minus 3 to the x from 3 to the x. That divides out. And then you have 3 to the x ln 3. Now, could I clean this up any further? You could. This can distribute. And so you would have 3 to the x still on the outside. You'd have 3 to the x times ln 3 plus 2 ln 3 minus 3 to the x ln 3. Well, look what happened there. These are the same, but they're opposites, so they go away. Now, don't forget, this is all over the denominator. I'm just running out of room here. Over your denominator squared. So let's see what I have left. I've got a 3 to the x on the outside. These cancel because they were opposites after I did some distributing. I have a 2 ln 3. And then on the bottom, I have 3 to the x plus 2 squared. Now, there's several other ways of doing this. Like you could have distributed this in the beginning right up here, but it's up to you, however you want to try it with your algebra skills. That's fine with me. It's a hard one, but you just got to try it. It's not gonna hurt you. All right. Last but not least, let's do general log rules. So yesterday we did ln rules, and today we're going to do log rules. Well, the rule is similar, but just an additional thing. Okay, so the derivative of any log base a of x as opposed to ln of x. Remember what we did with ln of x? What did we do? We went 1 over x, right? But little did you know there's an extra piece right here. So it's going to go like this. It's going to go 1 over x, just like that. And then you're going to attach ln of the base. just like we were doing before. So we could have done ln of e, but that cancels out to 1. So that's why we always would write 1 over x. Now, if it's a u problem, it's 1 over u, ln of the base, times the chain. All right, so let's try this out. This would be 1 over x times ln of the base times this chain, which is 1. And so you're done. That's it. All right. What about for something that looks a little bit more complicated? Well, again, don't forget your log rules. Always, always, always try to remember your log rules. And the log rule with a power, you should always try to bring it down. So put that 5 in front, log 7 of 6x to the 4th plus 3. All right, and what are we going to do? Well, keep that 5. It's just a coefficient. You can just get tagged on. You put it over 1 if you want to. Times the log of anything would be 1 over that whole thing, 6x to the 4 plus 3, ln the base, and then multiply by the chain of this. The derivative of that is 24 x to the 3rd, and then the derivative of 3 is 0. And then you can clean this up. Sorry, I'm getting distracted by 5 times 24x to the 3 would be, I believe it's 120 x to the 3 over 6x to the 4 plus 3 ln 7. And you could probably factor out a 3 from here and then reduce it with that. Let's do that. So let's see, if I factored out from that, that'd be a 3 times 2x to the 4th plus 1 ln 7. And any monomial can cancel with any monomial. And that goes in 40 times. So really, a better answer would be 40x cubed over the quantity 2x to the 4th plus 1 times the ln of 7. And that is a much better final answer. Hope this video helps.